Okay, well, let's just go ahead and get started. And I got about 2:01 on my watch. Thank you for attending another session of NextGen Geospatial. My name is Jeffrey Gillen, and I'm a data science, what am I, a data scientist, I suppose, and data science educator here at the University of Arizona. So coming to you live from the library here on the U of A campus in Tucson. And so this is, I guess, session 7 or 8. We have two more. So today is one, and then next week will be our final one. So just going through October. What are we going to talk about today? We're going to talk about geospatial data APIs or application programming interfaces. So I'm going to show you some examples of how you can get geospatial data directly in a programmatic way, as opposed to going through a website and clicking through graphical maps and stuff, which is usually a great way to do it, but we can actually do it with Python or other languages, and we can automate and scale some of our data extraction or data download from data providers. So that's what we're going to talk about today is geospatial data APIs. So up here, I have the course content as always at this GitHub address. Carlos already pasted the course content or the course homepage into the chat. So this is where I always start out. And let's go all the way down to our calendar. Thank you again, Carlos. All right, we've gone through all this stuff. It is already October 22nd. And we're going to be talking about, geospatial data APIs. So I'll go ahead and just click into the lesson. And here's our material. All right, so we'll be discussing data APIs. What are they? Why you would use one? And then we're going to show some hands-on example using satellite imagery from Planet. So this is all going to be around Python, and we'll be doing our example running a Jupyter Notebook in Google Colab, like we typically do. So I'll start with Planet. What is Planet? Planet satellite imagery. If you are a student, staff, or faculty, some kind of personnel or affiliation with the University of Arizona, we have prepaid for a campus license to get a whole lot of Planet imagery. And so if you would like to get a lot of free imagery from Planet, most of that being 3-meter resolution multispectral imagery, if you'd like to get this free imagery, you would click here. So please click here to learn how to get your account and start getting free imagery. If you click in there, it ends up going to a web page, U of A web page, and here's where the students can sign up or a researcher can sign up. And so this does take a human behind the scenes, my colleagues, to actually see that you signed up and then put you into the system, into the Planet account. And so then you are actually using our campus license. But please do so. I mean, this is free data. We paid a lot of money for it, and we would like it to get use. So please, the data is, there's a huge archive of it. I'm not sure how far it goes back, somewhere around maybe 2015, something like that. And then it goes all the way to present day. And so they get imagery up on the web for download almost immediately. So I could go on their search website and find imagery from probably yesterday, of Tucson, just available for me to download. And so, yeah, Planet is just really incredible in terms of their coverage, their geographic coverage and their temporal coverage for all kinds of applications. Okay, so enough with the sales pitch of Planet. It's great data. Please check it out. And you can get it for free. So for a tutorial, we have something in the chat. Is there new Planet Tanager 1 data available? I don't know. My guess is probably not. Tanager is hyperspectral imagery, I believe, from Planet, and that's kind of a new constellation they are putting up. My guess is probably, is that a yes? Yeah, okay, yeah. My guess is, so we do this every year. We just make a contract with Planet every year. So the last contract was probably made back in January or something. My gut says we probably don't have Tanager. Yeah, I don't know how to say it, but I don't think we have that hyperspec in our license. Maybe next year, as we kind of like renegotiate our license with Planet. Okay, so the tutorial is going to be using Planet data. Instead of the typical way of, you going on a website and looking through a map application to find imagery of interest to you. We're going to show you how to do it kind of in a programmatic way. And to do so, you have to have an API key. So if you have not signed up, we're not going to be able to get you your API key this quickly because we do have to push a couple buttons for you to get your account. But you could just follow along, and then maybe this is recorded, of course, and so then down the line, if you want to then figure out how to do this, you can always watch the recording. But yeah, for me to tap into the API that Planet provides, I have to have an API key, which is a permission. It's a way to connect my credentials to the Planet website. And how to do that, I can just go to the actual website itself. So here I am at planet.com, and I signed in with my U of A credentials. And if I go into, what do I want to go into? My settings. To my settings, then here's where you can get your API key. And we're going to use that API key in the Python here in a little bit. Let's go ahead and copy it. My goal is to try not to show my API key in this recording. That may not be possible. I might have to change my API key after this. Oh, thank you, Carlos. You posted about the hyperspec satellite. Yeah, when that really becomes, I don't know, is it online already? Like that data? I wonder if it's ready, but maybe limited. Yeah, it'll be pretty powerful once they get like a whole hyperspectral constellation up, orbiting the Earth. That'd be really great. All right, back to the lesson. So you heard about the API key. If you're not able to actually, click the buttons this time, that's okay. You can just kind of watch and you can do it on your own time, I suppose. Okay, so with that, let's get to kind of the little bit of the lecture aspect of it. And I like to start out with geospatial data is everywhere online. I mean, it's just everywhere. The world has really grasped the concept of GIS and remote sensing data for all kinds of applications. There's a lot of places to get it. Did you know that 1,600 or so satellites are orbiting Earth right now, snapping photos? 1,600 around the clock in almost every conceivable band or frequency. Planet itself has 200 satellites, I think. And yeah, and they are capturing the surface of the Earth, like the land mass, pretty much every day. It's just an incredible data set. This image here that I'm showing is Planet is actually doing some more kind of like value added products besides just imagery. They're actually doing things like forest carbon. I believe this is part of the they call it planetary variables product, and I believe some of that is included in the license. It's going to be at a lot lower quantity, but there is some available for checking it out, testing, things like that. This next graphic is just showing the fleet of NASA Earth observing satellites. There are a lot. but we're not going to do NASA today. We're just going to stick with Planet. And so how are we getting all this data? So the vast majority of geographic data, geospatial data, typically we'll get it through a graphical website. Earth Explorer is a pretty good example of that. This is the USGS, and this is where you get a lot of satellite data, like Landsat and MODIS, but also lots of other geospatial data. There's the national map. There's another place, and there's several dozen kind of locations online where you can search through a mapping interface with some filters to find data of interest to you. You find what you like, you click a button, and usually you do some kind of order, and then you download it. Right? It works really great. However, there is a more data sciencey way to do this. And if you're watching this tutorial, maybe you're interested in doing it the hard way. The hard way being doing things programmatically through a scripting language like Python. And yep, so we're going to use something called application programming interfaces, or APIs. So an API is a very kind of general term that can be used for a lot of ways you interact with a computer. But we were specifically interested in data APIs that are served on the web. And so a data API is it just has a URL, just like like a website, uarizona.edu, that's a website. But the APIs have their own specific website, and they are not an address you go to interact with it with a browser or your mouse. That's a website specifically that you hit with a scripting language to get data. And Planet has a few of these that are set up directly on URL addresses, and so you can just tap directly into them to get data. Allows you to circumvent and just get around and not have to do things graphically through a web page. So for the hands-on example today, we're going to be using a type of API called a REST, or RESTful API, representational state transfer. It's just a very common way that people can put data out there for people like you and me to consume. Typically how we request things through this API is using JSON or GeoJSON file format. And so that's what we're going to be doing with this REST API that from Planet to get Planet data. What else? Yeah, so why use APIs when to get data when web browsing is so much easier? I probably kind of already mentioned this. If graphical user interfaces and websites are so easy, what's wrong with it? What's wrong with it is scaling and automation. If you want to do something with Python, you're bringing it into a scripting environment. And so things can be automated and done systematically day after day without you hitting it or without you doing it manually. You can increase reproducibility and sharing of research with this way. Instead of downloading data and like trying to send it to my friend, I can just give him a script, and that script will download the data directly from the API. What else? Handling large data sets. If you are trying to get a bunch of data, satellite imagery, for instance, doing so through the website and clicking, and that might be hundreds or thousands of clicks later. It could take you hours and hours to do. Programmatically, you could write one script and then the whole thing could just run automatically, and you could just start pulling down data left and right and bring it directly into your Python environment, where it can then be passed to any kind of analysis you want to do. So yeah, so just like most reasons why we use scripting, we're trying to automate, scale, things like that. Real-time data processing. That's another kind of feature of something you might want to do with APIs. Okay, well, let's just go ahead and start the hands-on exercise here. So again, we're going to be tapping into a Planet satellite imagery API. We'll be doing so in a Jupyter notebook hosted on Google Colab. And I'll just go ahead and click in. Link, new tab. Okay, so here I am. And yes, I apologize if you do not have a Planet account yet. You're not going to be able to have a Planet API key yet, which means you probably can't actually click through the Jupyter notebook. All right, we'll go drink. Okay, so here we are in Jupyter Notebook, hosted on Google. This is called Google Colab. Thank you, Google, for the free computing. It's not very big, but it's enough to do simple things. Really good for teaching. So the first thing I need to do is connect to my resources. And so this is just plain vanilla. We're not using any GPU resources, just regular CPU should be fine. Okay, and so the beauty of Jupyter Notebooks is these are all like pre-written Python, and all you have to do is go to each code snippet and click run or click play, and it should just do it. Same for me is the same for you. The only caveat is the API key. All right, so let's just start doing it. And so sometimes I just start out with basic stuff to get my bearings. So here I just wanted to know what is the Python version we are using in Colab. We're using 3.10.12. Okay, good to know. I think Python goes all the way up to 3.13 at this point. I don't know if Google specifically wants to keep it at 3.10. I don't know. I'm just always kind of interested in the versioning of software. Okay, and can do this pip freeze, which will basically show you all the different Python libraries that come pre-installed in Google Colab. And I'm always kind of interested, like what comes pre-installed, because sometimes if I'm trying to install new Python, it could conflict with what's currently in there. So yeah, just kind of like housekeeping stuff. All right. Let's import the libraries that we need for this Jupyter notebook. We need JSON, we need requests. I'm not really sure what time does, but a Python guru knows what the time library is. I don't. All right, this next function is just to help us with the human viewing of JSON. That's what this is here. And then next is our API key. So I have to stop the share for a minute. I'm gonna take that API key, gonna paste it in. Okay, Dan, thank you. Anything to do with the date time format is in the time library, if memory serves. Okay, so that's how you can do like timestamps or date stamps with things, I think. Yep. Okay. Thank you. Let's go back to share. Okay, I put in the API key and hit run, but then I deleted the API key. I wonder if that still holds. Let's see. I'll set this next one and I should learn pretty quickly if it works. Well, maybe not. Okay, so Planet has a few different what we call endpoints. You can think of endpoint as just a URL, like this is an endpoint, this api.planet.com/data/v1/stats. So that's an endpoint. It's a specific address. So Planet has a couple, has like, I guess they basically have two different APIs that we're going to hit. One that they call the quick search, and another one they call the orders API. So quick search that's more about exploration. That's more like, why don't you show me what data sets are available for this time or this place or whatever. And I think they allow you to just download one at a time. The orders API is more like, I would like to order 27 satellite imageries, please. So it's more like the production, like the quantity. You can do a much higher quantity. So you start with like the quick search, and then once you kind of know what you're after and have figured out your interest, then you can go to the other API and get it in bulk. All right. All right, next one we're going to start thinking about constructing our query for the data that we are interested in. And so first thing we can do is create an area of interest, like basically a box, a geographic box for what, the place on Earth that you're interested in finding satellite imagery. And typically how we do that is with GeoJSON. And what you're seeing here is a GeoJSON rectangle. Yeah, I think it's a rectangle here. Well, there's 1, 2, 3, there's 5, so maybe it's not quite a rectangle. A great website to make this, to make GeoJSON, polygons and then get the exact code of how to do it is geojson.io. So if I go to it, if I make a square here in the middle of, where am I at? Niger. Boom, it created the GeoJSON here on the right. And so it's a very handy dandy website to quickly make a GeoJSON file that specifies an area of interest, a geographic area of interest.
5 points.
It also had 5 points.
Because the last one, when you make a square.
Okay, the last one is the same.
Close to the next one. If you analyze.
Yeah, it's like this first one, the last one, right? Look pretty much the same. Okay. All right. Thank you, Carlos, for that. Okay, so we're going to create our little GeoJSON, which is an area of interest around Tucson. I think it is Mount Lemmon area that we are defining here. Okay, and so next thing we want to do is define some other kind of searching parameters or searching filters. And to really figure out like what the filters are, for any given API, you're gonna have to check the API guide. And so Planet does have a pretty good documentation on what the fields are, what the different filters are. But mine works, and so you can just kind of use that as a template if you want to do it in the future. All right, so what are we trying to do here? We're creating a geographic filter, and then I'm interested in a date filter. I'm looking for imagery, looks like June 2020. So June 18th to June 19th, 2020. So that's my date range. So June 2020, around Tucson. I would like cloud cover to be less than 50%. So that's kind of a nice filter. You can just get rid of, the days that are super cloudy. You can just go right by that. And so this final thing, this combine filter, combines your geometry, which is the GeoJSON, your date range filter, and cloud cover filter. So it turns it into this like combined filter object thing. Okay, and here is where we're actually going to start talking to the Planet API. Let's just click this and see if it works. And it's telling me Combine filter is not defined. Maybe I didn't click it. Okay. Aha, okay, so yeah, this code snippet here is where we're actually reaching out to the API and saying, hey, we would like this filter, the combined filter. So please search through your catalog, and return the filtered results to us and show us what you have. And of course, you have to have the API key for it to work. What else in here? Yeah, so this is a stat request. We're just trying to get kind of basic information about it. And what have we gotten? We found that there are 16 total, I think, items that meet that search criteria. And okie dokie. This one is going to do, let's just click this one. Forgot exactly what it's doing. Okay, yeah, so this is another API call. And for this one, instead of statistics, we want a quick search. And so this is actually it's gonna tell us more information about the individual items. And I just said, look at the first result. You could write something that is show me all the results, but for simplicity, and so it doesn't bleed like a million lines of code, I just said, show me the first result. And so it's showing me the basically the footprint of it in geographic latitude and longitude. It's telling me it's a polygon, and then all the different statistics, all the metadata associated with it. So Planet's really good at like really doing a very good job with all of their metadata. Cloud cover percent 0. Ground control true. I have no idea how they do ground control. Guess I'd have to look deep into their the recesses of their documentation. I don't know how they exactly do it. Ground GSD 3.9. So that means ground sampling distance. That means our pixel sizes are 3.9 meters in size. Heavy haze percent. Okay, I guess that's different than cloud percent, cloud cover. Yeah, they just have a lot of different metadata. And so I think when you're searching or filtering to find things, I think you could probably use like all of this metadata as potential filter parameters. Okay, just keep on going. This one, I just wanted to show me of the resources that are available. What are their ID numbers? Every Planet product has a specific ID number. I'm just curious what they're called. Looks like their naming convention uses date. Makes sense. Okay, so I've already pre-done this to make something interesting. So I wanted to pick an interesting image in all these images that meet the criteria. So I'm specifically interested in this ID image right here. And I know that because I've been going back and forth between the API and the graphical web page. That's what this is. This is typically how we search for things in Planet. And when I'm first looking for stuff, imagery in Planet, I use this. I use the website, right? Because that's the easy way. That is the way to find basically things of interest to you. And once I find things of interest to me in the web page, then when I want to like automate it or do it, with more volume, that's when you go to Python and the API, when you already have a better idea of what you're after. Just make a little thing here. Yeah, so I just looked for imagery within Tucson, and we have an image from October 22nd, which is today. Interesting. Okay, so what you're looking at here, I guess, is planet imagery from today. (1818) UTC. I don't know what time that is. You know, that's
11
Greenwich Mean Time, right? But I don't know like what that translates into now.
11 a.m.
What is it?
Yeah.
Yeah, but like what does 1818 mean for
11.
Tucson
We're
time?
We're
What-
7.
Just take 7.
7 hours.
7 hours before that. So okay.
11.
So 11 a.m. Okay. Wow. So just a few hours ago.
Yeah.
Wow. Very cool. Yeah, UTC 7. Okay. Subtract 7 hours, and that's what we are. -7. Okay. Thank you guys. Yep. All right. So, yeah, so Planet does a really good job of getting data. They must just have this amazing automation process. Because there's no way they're doing those things manually, right? Okay, so let's go back to our notebook. And so I was interested in this specific ID because I was on the web page and I looked at that image on the web page. I'm like, okay, yeah, that could be interesting. So let's just go ahead and get that specific image or that specific item, I think is what it's really called. Okay, and when I say show it to me, then it shows me, I think these are all the different assets. So those are the actual products, like orthoanalytic 4B, let's see, orthoanalytic 4B SR, that is surface reflectance. And so each item can have multiple assets. An asset would be like an actual like layer, GIS layer of different ways to look at it. Ortho visual, I'm guessing that's probably just like a thumbnail, something that's just easy to visualize. I forgot what UDM2 means.
Yeah.
Yeah, I see that UDM2. I'm just curious. What's that mask?
Data. Also, you had about usable data access. Cloud 2.0.
I don't know where you're looking. Oh, here, okay. Usable data mask. Okay, thank you. Usable data mask, cloud. Okay, that makes sense. Okay, next up, I now know the item I'm interested in. Here are the different assets that are available. And then what you have to do with their archive is you have to check if the imagery has been touched in 30 days. Apparently, if no one has touched that data in 30 days, it goes into cold storage and needs to be activated. So this is a little line to see if it's been activated. Hey, it's already active, and that's because I did it yesterday. If you find any other image, chances are you'll have to like send a request to have the image activated, but it usually takes like 5 minutes or 10 minutes for that to happen. So it's just one little extra step. Okay. Whoops. Don't need to run that. It's active, so I can just skip the send a request to have the image activated, skip the check the status of the asset now. I can just skip those things. And now I just want to get it. Okay, I do have to click these buttons. I should have written it away where I didn't have to, but. Okay, active, good. Now get the download link. Here's the download link. So this URL here is the exact asset that I'm after. Wow. Okay. And this next snippet is actually to download the image to Colab disk. All right, so that's going to download a planet satellite scene. I think the 4-band planet scope imagery scene to my Colab here. And yep, here it is. It's called Bighorn Fire. I did that labeling, like in my code here, I said call the thing that we download. We'll call it the bighornfire.tiff. So yeah, here's a GeoTIFF that I downloaded through the API, and I have it here in my Google virtual machine. I have a nice message saying image downloaded successfully. I love these like printed responses. It's very encouraging. Okay, so now that we have the image, now we can just visualize it real quick. To do so, I'm going to use raster.io. I'm going to use gdoll, matplotlib, so we can just take a look at it. Okay, I downloaded and then installed, imported the libraries I needed. Let's set the path. So that's the /content/bighornfire.tiff. That is where my newly downloaded satellite image is. Then let's take a look. Okay. How's it look? Didn't look so great in the Zoom, as far as I can tell. What you're looking at is a false color composite. So the near infrared band is being displayed as red. And so really that means things that are very green, right? So anything that looks bright red, that in real human color, that would be green. And so up here in the upper left, this is a golf course up here. So this is Mount Lemmon in 2020, June 2020, in the middle of the Bighorn Fire. So that's why I chose this. Just there's some action going on here. You can see the smoke plume from basically from the summit of Mount Lemmon. And for those of you who are in Tucson in summer 2020, you probably remember that couple months. I do. Okay, and so what did we do? We tapped into a Planet API, did a little bit of filtering to find an image of use, downloaded it to our virtual machine here, and I'm just displaying it. I'm not going to take it any further than that. So that was I believe what did they call it? Forgot what that API was called. Not the orders API. Was it the data exploration API? I can't remember what they call it. Anyway, it was about just exploring what you might want, downloading one thing at a time, bringing it into your Python environment. The next snippets are all about doing things in more of a bulk download. And so we're using a different API endpoint, but everything is the same. The procedure of what we're doing is the same, only we're hitting a different endpoint, which allows us to then get multiple products all at once. I'll just go ahead and do it, see if it works. Okay, so in this snippet, I'm just defining which items I'm interested in. Let's create an API request object here. Okay, and then we can send the request. It's called a post request. We'll send that request over to the API. Thank you very much. It's giving me, oh, it's in a queued state. Okay, looks like they got the order, and now it's being processed. It's preparing order. Okay, it's in queued mode. And the next snippet is to hit the API with that specific order request. So I'm probably going to have to change this URL. I have to change it and add this one. Order is still processing. Okay, so we have to wait like 5 minutes or something, and then it will process, and then I can download it. While we're waiting, I know so this tutorial of hitting the Planet API and getting data is still, we're still in the download model of doing things, right? This is not the cloud native model that I was hoping. Planet they do cloud optimized geotiffs, but in a kind of a roundabout way. So if you order something from Planet, like on their website, you order a satellite scene, you can either download it or you can, I guess they say, host it on their service for analysis. And if you do the hosted by them, then it becomes a cloud optimized geotiff, and then it can be streamed to anywhere. But this API, I don't think you can stream hogs cloud optimized geotiffs directly from the API. The API is just for downloading. Yeah, I would love it if they just had the entire catalog in a served up cogs that you could just stream. But I'm guessing at the volume that they do things, that might be difficult. Thank you, Alan. Alan was saying maybe my API key is exposed in the recording. That's totally possible. Easy fix. I can just go back to Planet and get a new API key, change the code, and I'm all good. Thank you, Alan.
You can put the key inside the Google so that.
This thing?
Yeah.
No, I don't know how to do that. Carlos is saying that you can put an API key here.
Add new secret,
Okay, so you put it
Yeah.
here.
name, planet.
Okay, and then I would paste it in here.
Yes.
Okay,
See it on that. So he will take it from there, so you have to be exposed every time.
okay. Oh, thank you for that. Yeah, I didn't know that. Didn't know that tool was there. Okay, nice. And so just, does this persist? Once I close my session here and like I
It's
will
part of
still,
Your account.
okay, it will persist with my account.
Yes.
Okay, yeah, thank you. Okay, and so you just add this little thing here to like bring in that API key. Yep, okay, nice. Thank you. Okay, order is ready. Where's my order? Oh, that was from. Okay, I haven't downloaded it yet. My order is ready, but it's not been downloaded. I have to push one more button. Okay, Dan's saying, and use the same name you put in the list of keys. Yep, okay. Thank you. All right, so let's download those images. Boom, here they are, start popping up. Okay, looks like it's complete. Yeah, so if you're working in Colab, you know, we've downloaded these things to Colab, you know, virtual machine. You can always just download them, click the three button menu here, and you can hit download, and then I'll download to your actual local machine. Okay, well, that is all I wanted to show you guys. So just give a little demonstration on how to query and retrieve geographic data from a data API. We use planet satellite imagery as a example of how to do so. I was looking to see if there are other, where else can we hit APIs? And I was not all that successful, to be honest. If I go to USGS, I don't think they have a data API for a lot of their stuff. It seems that a lot of people are still not, at least a lot of like institutional or government data portals. A lot of them are still not like,
Usually it's commercial.
yeah, exactly. A lot of that are still not using APIs to distribute data. I hope that changes. But that seems to kind of be the reality. So Planet is kind of maybe unique in that space. Yeah, and that's it. So thank you very much for your attention. Hope to learn a little bit about data APIs, how to do an example of it with Planet using Python. And what else in the chat? Yeah, NASA may have APIs. That's possible. Yeah, through my explorations a few months ago, I think I kept coming up empty and empty and empty, like trying to find places that I typically get data, and you still had to do it, you know, through the website and stuff like that. So that is it for today. Next week, the final session of NextGen Geospatial for the semester, we will talk about spatial temporal asset catalogs, or STAC. And so that is kind of an open source way that we're trying to build a global catalog of geospatial data, kind of an open way. So we're going to talk a lot about metadata and how we describe data and how we make that data discoverable, and how we make a standard API. And so in a way, you can make all of your geospatial data, if you are a geospatial data, you know, producer or provider, you know, everyone in the world could just basically have one single API, one standard API for us all to find geospatial data. So we'll talk about that next week. So thank you very much, and we'll see you then.